Pressure. What is this pressure? Pressure is the force acting over a unit area, simply to say, right? When you apply a force over a surface area, the total force you apply over a certain area, the total area, when you take both, you take as a ratio of force over area. This is how you calculate the pressure. So this is actually the solid pressure. Means pressure can be applied in all three mediums: solid, liquid, gas. Solid, liquid, gas, all three. So medium to medium, the way the pressure is acting, the laws related to pressure are different. All right. So take an object. Find an object here. Over another surface, you're going to apply a force. You're applying a force. And this is the surface area where it is contacting with. Okay, the entire part. It is the surface area. The force you are giving here is F. Area here is A. How do you find out the pressure? Pressure equals, we term it as the perpendicular force. What is the force we are taking here? Perpendicular force. Perpendicular force over contacting surface area. So P is equal to F over A. P is equal to F over A, where the force is measured in newtons, area is measured in square meters. So pressure should be Newton per square meter, which we take equal to Pascal. Right? So 1 Newton per square meter is equal to 1 Pascal. 1 Newton per square meter is equal to 1 Pascal. So Pascal is the standard unit that we use to measure pressure. Alright. So P equals F over A. Now the relationship between these, right? When we take the relationship, P equals F over A, P equals F over A. Right? Let's say if we're gonna keep the area constant. Area is constant. Who is constant? Area is constant. You don't change the area. Then the relationship between this P and F gonna be like this. P is directly proportional to force. Means without changing the surface area, you push it harder, you apply the force more. Now what happens? When you increase the pressure, when you increase the force, pressure increases. Directly proportional. Directly proportional. When you decrease the force you apply here, you reduce it, then the pressure acting over the surface will be reducing because you didn't change the surface area. You didn't change the surface area. Same way, when you're gonna take this, if let's say the force you're gonna change, you're gonna keep the same, you're not changing the force. F is constant. Who is constant here? F is constant. You are changing area, keeping the force same. P and A, pressure and area, you can see it is inversely proportional. An inverse proportion refers to keeping the same force here, you increase the area, pressure decreases. You decrease the area, pressure increases. So, what is the relationship here? It is inversely proportional. Here we took direct proportion, here we take inverse proportion. Inverse proportion. So, this is the proportionality between the factors here. And according to our requirement, we change one factor in order to either increase or decrease the pressure. So usually when you are taking the blades, scissors, cutters, any sort of things that you use to cut, knives, usually they do have a very small edge, right? Surface area is very less. The nails you take, the surface area is very less. The pins, right? So all these, the thumbnails, right? All of them are having a very small surface area, very small surface area. As the surface area is very low, even you give a smaller force, pressure would be high. Pressure would be high, right? Because the surface area is very less. Okay. So when you take your school bag, you do have a broader strap. Why? Surface area is higher relative to smaller straps. So you do have the same set of books. Two bags when you use, one is with a larger, a broader strap, the other one with the smaller strap. You can see broader strap when you hold up with, you want to feel the pain, or the pain that you feel over your shoulders would be less. Means the pressure is less. What is the reason? Surface area is more. Surface area is more. So the pressure is less, right? So accordingly, in our day-to-day activities, as per the requirement, we use that. Okay, fine. So this is actually the solid pressure. Solid pressure. So the solid pressure part is very easy. As an example, let me take a question here. Let's say if force is 25 Newton, right? Force is 25 Newton. And the surface area is given 5 square meters. How much is the pressure? A very simple form. Okay, how much is the pressure? How do we find out the pressure? Pressure equal force over area. Pressure equals force over area. How much is the force F? Force is 25 Newton dividing by area 5 square meters. First, you have to write the formula, substitute the data, get the final answer 25 over 5. It's 5. Pressure we measure in pascals, 5 pascals. Very simple. As per the question, you have to rearrange. Rearrange. That is one point. The second point is, if it is giving you any of the units like square centimeters, or it is giving you the kilograms, how to convert into newtons. How to convert? 1 kilogram is probably equal to 10 newtons if the gravity is 10, right? So that way you have to convert. And then square centimeters, you have to convert that into square meters because the final answer should be in pascals. Okay. So this is the part, the basic part about the pressure exerted by solids. Pressure exerted by solids. And this pressure, it is not always vertically down. It may be vertically up. It may be in any angle, any planes, okay? Any planes. But always in these calculations, we take the perpendicular force. Example, let's say I'm hitting over the board. Now, board is a vertical plane. But I'm giving the horizontal force, right? Then the horizontal force I'm giving should be perpendicularly taken. The perpendicular force over surface area I have to take. And we don't take the total area. For example, let's say this is the object. The entire object's area we don't take. The object's surface line is contact. If this is the surface contact, that is the surface area I have to take. Okay. Sometimes the question gives you with the measures like length, width, height they will give. So you should clearly observe which surface is contact. And to that surface, what are the units, what are the measures given as the length, width, or whatever. Those only you have to use to find out the area. Okay, so that way also the questions could be built up, right? So can I write this down quickly? Take a small note about pressure. So this is the formula that we are using now. Pressure equal force over area. P equals F over A. Right. So let me take the liquid pressure. Now to learn about the liquid pressure, you should have an idea about this part. Okay. When we take the liquid pressure, that is the pressure exerted by any liquids. Any liquid. There are some basic principles about this liquid pressure. Okay. What are the basic principles? We term it as hydrostatic pressure. Basically about what we gonna speak, right? Now this hydrostatic pressure when you take, there are some basic principles that is. Let's say it's filled up with water and you make some holes everywhere randomly. Okay. You can see from all the holes water spouts out. From all those holes water spouts out. What it means? It means that pressure of a liquid acts in all the direction. First point, right? Liquid pressure exert in all the directions. It is acting in all the directions. All the directions. That's one. And the second one. Let's say you're gonna take a container like this. Okay, you're going to take a container. You're going to take a bottle of something, right? And you're gonna make the holes at the same level. You're gonna make the holes at the same level. You have liquid level up to this, and you see water spouts out at the same speed. How do you find it out? When you keep the bottle over a surface and just below that you do have a clear ground or clear something like a tile or something else, let's say, where you can see where you can get the observations clearly. You can observe water. Let's say a paper you have kept. You can see the place where water spouts out and touches the ground. Okay. From that point to the center of the bottle, all of them are having the same like radius. Same like radius. That shows you that all 4 points are spouting out water at the same speed. Why same speed? Pressure is same. How come pressure same? Because same level of water they are above. Same level of liquid column is there above the point. So as far as there's an equal, identical level of the liquid column above the point would be exerting the same pressure. Same pressure. So it is clear that height of the liquid column is affecting the pressure. Height of the liquid column is affecting the liquid pressure, right? So furthermore to elaborate, we take another diagram, something like this. I have another liquid column and I'm going to make the pinholes at these points. And I could see water spouts out at different levels, different ways. The lower one would be spouting out faster. And when you go up, the spouts come closer. Spouts come closer. What is the reason? The reason we are taking. Let me take this as the points A, B, C, D. When you take the point A, this is the height of the liquid column above the point A, right? And when you take the liquid point B, this is the height of the liquid column. And point C, it is the height. And point D, this is the height, right? So we take the liquid columns here, liquid column of A, B, C, D. Who has the highest liquid column? A. Above A and then B and then C. D has the lowest. We don't take the depth down from the point where the pressure is considered. Above that, how much water level is there? So you can see this is the level of water here. This is the level of water. So water level is greater in A. The height of the liquid column above the point more means it exerts much more pressure. So I can see the pressure given at A is more than the pressure at B, and then C down, the lowest one is D. Okay, so that is the variation of the pressure. But the thing is, should be having the same level of liquid, and probably when we keep it over a flat surface, a flat maybe a table or something, You can see without an angle, without an inclination when we place it, you can see the same level of water will be there. Let's say the water level goes down like this, then we can't compare in that. It should be the same level of water. Okay. So these are three fundamental points about the hydrostatic pressure. Right. Now, how do we calculate this pressure? How do we calculate this pressure? I'm going to take a container like this, a tube. Right. I'm going to measure the pressure at the bottom. The pressure I want to measure at the bottom of. So this is the liquid I have. The liquid I have. So the liquid does have a density. I take the density as rho. And there's a gravity down, right? It is G. And the height of the liquid column here, up to this point, I take it as the height H. Height H. Right? So how do we measure this? Calculate this pressure. How to calculate this pressure? The pressure equals height of the liquid column into gravity into density. All the way rearrange it. It's easy if we are taking the density first. Height, density, and the gravity. So P equals H into rho into G. P equals H into rho into G. Yeah. Right. So you see P equals H rho G. The height we have to measure in meters. It cannot be in centimeters. It's meter. Rho should be kilograms per cubic meter. And gravity is meters per square seconds, or as you can take it as newtons per kilogram. Newtons per kilogram. So this is the formula that we are using to find out hydrostatic pressure. So this is the calculation. It is the calculation. So here, now the gravity is same, right? Gravity cannot be changed. So without changing the gravity, let's say the rho you increase, height is also same. Okay, height is also same. If height is constant, who is constant? Height is constant. If the height is constant, gravity anyhow same, right? Gravity is same. Then P will be directly proportional to rho. Rho means density. Okay. So rho you increase, pressure increases. That means you give the same height for two different liquids and measure the pressure at the bottom. Okay, let's have an example. Water and mercury. Mercury you take. Mercury is about 13,600 kilograms per cubic meter. Whereas water has only 1,000. So you can see there the density is very high. Having a higher density gives a high pressure. So density more, pressure would be more. You reduce the density, pressure would be reduced. Okay. So this is the relationship here, but the condition is height should be the same. Gravity is anyhow same. Okay, as far as it is on the earth. And let's say now, if rho is same, you are comparing only for water. But two instances increasing the height. Then what happened? This P, something like this example, P is directly proportional to height. For the same liquid, you increase the height, pressure increases. You decrease the height, pressure increases. You decrease the height, pressure decreases. So this is the comparison, okay, between the factors. Okay, so these are the fundamentals with the equation of hydrostatic pressure. Hydrostatic pressure. Right? So can I take a note quickly? The first figure says that pressure acts in all directions. Pressure at the same level, points on the same level will be having the same liquid pressure. When the height is increased, pressure will be increased. They are the 3 points here. Yeah, this is. We were actually discussing about pressure. You have a small note before this. This is. You have to keep a small space actually, one page like you have to keep, and then take this note as hydrostatic pressure. And this is actually a part in our syllabus as well. We have this pressure part.
Sir, excuse me, sir.
Yeah, this is.
Sir, what is L and P?
What is? Yes, what is?
L and P. In the first one,
Yeah, L is the
LA is
to the
larger than
length of A, length of B, length of C, length of D. Okay, P is the pressure. P is the pressure. So actually, Sharin wanted me to do a small part from this since he is having the exam. So we are having a small revision. Okay. And he wanted me to do electricity also. So after this, I'm taking the electricity part. Just to remind the theories. Okay. And this part actually we do also have in our curriculum. That means in our lessons also we do have. I think I have almost done with the forces, waves, electricity. So the next part about the solid, liquid, gas, and we are discussing, we have to speak about this pressure, density, and all. There once again we'll be taking the theoretical part, bit expanded with calculations, examples, and all. We'll speak about. So since this is the revision, a sort of review he especially need we were discussing actually about. And now we'll be switching up with the electricity part. Sharin, probably you'll be having a problem with that electric circuits, correct? Is that so? Maybe finding out the voltage, electric current, those stuffs, right? Yeah. Give me a thumbs up once you're done. Karen, are you done? Okay. Let me send you a paper now related to electricity. Okay. We're gonna write answers for that. Some of the circuits. Okay, some circuit questions. Take it from your group. So this is the question paper. The circuit shown in the diagram uses 12-volt battery. Okay, 12-volt battery. Have you seen one point? A dry cell when we take, it is one symbol, only one symbol. All right. When there are two, like 3-volt, we draw two. But more than three, probably we mark it between the two, some short lines, dotted lines like. It refers to it is a battery. So 2 or more dry cells when they are connected, that is called a battery. So you see, 12 volts means almost how many cells are there? Can you tell me? In 12, how many cells are there? 8 cells are there, right? 8 cells are there. All 8 cells we can't draw here, right? So that either side, the first and last one we mark, and in between we are marking with a short dash line to indicate that that is a battery and that has some more cells between, right? So switch S is open. So the switch here is open. As shown in figure 10.1, state the value of the reading on the ammeter. How do you read the ammeter reading here? As shown in the figure. State the value of the reading of the ammeter. How do you find it out? Switch S is open. Okay. You don't want to think more. The switch S is open. Open means it is turned off. Not yet turned on. Okay. It is not connected yet. There is no current passing actually. Then what will be the ammeter reading today? Ammeter reading would be 0. Ammeter reading would be 0. The reading on the ammeter will be 0. The potential difference across S. What is the potential difference across S? What do you think? What do you think the potential difference is? Potential difference is 12 volt. Potential difference is 12 volt. Why 12 volt? Because even if it is connected or not, right? 12 volt supply is given by, okay, when it is not passing a current, even it does have that 12 volt potential difference. So the current is 0 if it is not connected, but the voltage is still the same, the 12 volt. Okay, right. Please write the answers, put the question numbers 1A1, Roman number 1, Roman number 2, it's 12 volt. B1. Question asks you. Switch is now open, now closed. Switch is now closed. You are going to connect it. Calculate the current in the ammeter. How do you find out the ammeter now? Ammeter reading now? You can see once it is connected, there are two resistors in the circuit. Okay. For this question I have given you because it covers some resistor area also. Basically, we'll be having problems with this resistance. Okay. So when we cannot take this resistance, you know that. Okay. Resistors can be connected in two ways. What are the two ways? One is series. One after the other. Okay. So how do we find out the total resistance here? Total resistance R, I'll take it as RT or as RE, is equal to R1 plus R2 plus R. So in series, where one after the other they are connected, straight away we have to add them to get the total resistance value. Okay, straightly we have to add them to get the total value. And let's say it is parallelly connected, something like this. Same three values are taken. And I'll take it as R1, R2, R3. How do you find out the total resistance? We have to take the reciprocal of the total. Total also we are taking the reciprocal. Is equal to the sum of all the reciprocals. That means 1 over R1 plus 1 over R2 plus 1 over R3. 1 over R3. So these are the methods, the two methods to find out the total resistance in series and parallel respectively. Okay. So in this question you can see, it says, now the setup is closed. So let me write the answers there. The question A, 1, we took 0, 2, we took 12 volts. Now B1. Question says it is closed now, it is connected now. Calculate the current in the ammeter. How do we find out the ammeter now? Ammeter reading now. Find out the ammeter reading. First, I want to find out the total resistance here, right? Total resistance. How much is the total resistance? 16 ohm and 8 ohms are connected in series, one after the other. Okay, one after the other. Let's say this S is closed. 16 ohms and 8 ohms resistors are connected one after the other. So first I want to find out the RT, total resistance. Total resistance equals 16 ohm plus 8 ohms, which is 24 ohms. 24 ohms. So the total resistance is 24 ohms. Now I'm applying V equals IR and I want to find out I equals V over R. I equals V over R. How much is the voltage given? Voltage in the circuit is 12 volt divided by total resistance I got here was 24 ohms. So 12 over 24 means 1 over 2. What it means? I equals 0.5, it is measured in amperes. So what is the ammeter reading here? 0.5 amperes. So what is the ammeter reading? 0.5 amperes is the ammeter reading here. So that is the B1 answer. B1 answer. Switch is closed, calculate the current. So the current is 0.5 amperes. Calculate the potential difference across the 8 ohm resistor. Now this is the 8 ohm resistor, right? 8 ohm resistor. You want to find out how much potential difference is there here. Now you see, current is same, right? It is a series connection, 0.5 ampere current passes. Same current passes throughout the circuit. Same current passes throughout the circuit. Okay. So 16 ohm resistor also allows the current of 0.5 ohm, 0.5 amperes. 8 ohms. 8 ohms resistor also allows the same current of 0.5 ampere. Ammeter also records the same. Across the voltage also the same current, series connection. So now I want to find out what is the voltage at each specific levels. Total voltage is 12 volt. And this total voltage of 12 volt is what shared between 16 ohm and 8 ohm resistor. And we consider that ammeter does have no voltage drop. No voltage drop means not a big amount of voltage drop. There will be. But we don't take it into the calculations. Considering that no resistance there, right? So I want to find out how much voltage drop is there at 8 ohm resistor. So what I do at this second one, I apply V equals IR at 8 ohm resistor. V is equal to I into R. At 8 ohm, the resistance is 8. Current is 0.5. Same current passes, resistance is 8. Only for 8 ohm. So, current 0.5 amperes into current 0.5 amperes into, okay, what is the resistance? 8 ohm. 8 ohm. 0.5 into 8 means half of 8. Half of 8 refers to 4. 4 volts. 4 volts. So out of the 12 volts given, how many volts are used at 8 ohm resistor? 4 volts. That means the remaining 8 volt should be at the 16 ohm. 16 ohm or else the remaining one. Okay. So that is how we take the question here. Got the point? And then, let's see, they are here. The next one. The two resistors are now connected in parallel. Now you are going to connect both the resistors in parallel. Calculate the new reading on the ammeter when S is closed, stating clearly any equations that you use. Now what do you mean by that? Now both the resistors you are going to connect in parallel. Parallel means how do we find out the resistance? Total resistance. The same method I have to follow up, but now the equation is different. Why? Earlier we took series connection, so total we took 16 plus 8 directly 24. Now I can't use it now in this C part because the C part says that it is no more series, it is connected in parallel. So first I want to find out at the C level here, I want to find out the total resistance. How to find out the total resistance? 1 over R. I have to take it as 1 over RP, correct? 1 over RP. So this 1 over RP should be equal to 1 over, one person is 16, the other person is 8. Correct? Only two people are there, right? One is 16, the other one is 8. Now, how to take it as 1 over? Now, it is 1 over 16. I can take the LCM. Straight away, I can write it as 8 times 2, 16. So, 1 times 2, 2. I have to take. So, it is 2 over 16. So, 1 over RT is equal to 1 over 16 plus 2 over 16. I can take it as 3 over 16. Correct? 1 over RT is equal to 3 over 16. 3 over 16. Means RT should be equal to 16 over 3. Correct? RT should be equal to 16 over 3. 16 over 3. Tell me how much is 16 over 3? It gives you 5.33. Right? RT is equal to 5.33 ohms. 5.33 ohms. Okay, you got the point? Since it was series, yes, straight away I added. But the same thing you can't do in the C part here because it is parallel now. The question says it is parallelly connected. Both of them are parallelly connected. Parallel connections I have taken as 1 over 16 plus 1 over 8. So taking the LCM, I get 3 over 16. So 3 over 16 means 16 over 3. 5.33. It is my total resistance. Now what you want to find out? You want to find out the ammeter reading. Ammeter reading. V equals I into R. So I equal, hence V over R. Okay. Voltage is not changed, right? If you are giving 12 volt, the same voltage is given throughout. Let's say 12 volt input voltage you go give. For all the resistors you are connecting in parallel, will be having the same voltage. Earlier it was 4 volt, right? Because series. But now all of them are connected in parallel means all of them will be having the same voltage for both the terminals. So the voltage is 12 volt divided by 5.33 ohms. Okay, I can take it as 5.3 as well. Right? 5.33. So 12 volt dividing by 5.33, I get the answer 2.25. 2.25. Can you see now what happens? Current has been very much increased. Current has been very much increased. Okay. So remember, when the resistors are connected in series, resistance value will be high. 24 ohms. When the same resistors are connected in parallel, very much lower it falls down. So resistance, total resistance is reduced when they are connected parallel. So again, I'm telling you, when the resistors are connected in series, total resistance increases. When the same resistors are connected in parallel, total resistance value drops down. You can see how much it is dropped down. Okay. So in that case, when the resistance is reducing, current will be, you can see current will be increasing. Resistance decreases, current increases for the same voltage. So you can see the voltage, the current has been very much increased. Current has been very much increased. Sometimes in this question, they may connect one more thing. What is the other thing? They may say that there is a fuse connected. There is a fuse connected. Okay. Let's say the fuse is 2 ampere fuse. So fuses we are connecting in order to control the current, excess, the maximum current. More than that maximum current, if a current is trying to flow, the fuse goes out, okay, to protect the devices. Now let's say the question asks you, can you use that 2 ampere fuse for the first setup? Yes, because first setup gives you 0.5 ampere current only. Can you use that fuse for the second setup? You can't. Why? Second setup's current is, minimum current is 2.25. So minimum current 2.25 means where you have only 2 ampere fuse, definitely it doesn't allow the current to pass on. Understand? There won't be a current passing in that because the fuse goes off when 2.25. More than 2 ampere current is trying to flow. You got the point? So this may be connected with fuse also. So that is the answers. They are the answers for the first question. I hope I have taken the theories also related to. Fine. Any questions over there here? Okay. So can you please go to the next one now? I want you to try the second question. It's related with, I think, the power. Power, voltage and all. Yeah. Power is there. Yes. Charge passing. So let me remind you the equations there. Okay. Let me remind you the equations. Using those equations, you have to find out the answers for that. What are the equations? Power equals voltage into current. Power equals voltage into current. Okay, this is how you find out the power in electric circuits. Power equals voltage into current. Okay, and then energy is equal to power into time. Power into time, because power is equal to energy over time. Right? So let me write it again. Energy. Power is equal to work done or energy spent over time. How much energy transferred per unit time is called power. So rearranging the equation, E, energy equals power into time. Energy equals power into time. Okay. And for power, I can use VI, right? For power, I can use VI. So what can I say now? E equals V into I into T. E with. E with or else ITV also we can say. So E equals power into time, but power is equal to voltage into current. So if voltage and current are given, you can straight away write here voltage into current into time. Current should be taken in seconds. Okay. Power is measured in watts. Power is measured in watts. Okay. Voltage you take volt, current you take ampere. Power is in watts. Time you have to take in seconds. Energy will be in joules. Energy will be in joules. Okay. And then I is equal to Q over T. Charges flowing per second. Charges flowing per second. Okay, I equals Q over T. How much charges are? These are the electric charges. How much charges are flowing per unit time? That is called current. So probably these are the three equations needed for this question. Okay, so using them, could you please get me the answers quickly? Give me the answers quickly. Any other equations needed? Refer to the note and get it on. After you have done, I will discuss the answers. Okay. Question 2 in that paper, question 2, the paper I have sent you. Question number 2 you have to do. So give me a thumbs up once you are done with that question. What's going on? Are you done? I'll let me give you 2 more minutes. Okay, and then we'll start discussing. Okay, make it fast as much as possible.
Sir, I'm done.
Okay, let's discuss then. Figure 8.1 is the plan of a small apartment that has 4 lamps as shown. Okay, 2 into 60 watts. That means 2 lamps are there, each at 60 watts. 60 watts, that is a power. Okay, 100 watts in the kitchen and 60 watts in the bathroom. Power for the lamps is supplied at 200-volt AC. AC refers to alternative current, right? Alternative current means which changes the direction, okay, while it flows. It doesn't have one definite direction. One definite direction means direct current. And the lamps are in parallel. All the lamps are in parallel. So usually when you come for the domestic circuit also, you do have a parallel connection, right? In the space below, draw a lighting circuit diagram so that there is one switch for each room and one master switch that will turn off all the lamps. Okay, label the lamps as 60 watts or 100 watts. All right, how do we do that? How do you make it? So 4 lamps are there, and the question says that all of them are parallel, right? All of them are in the space below, draw like and the lamps are all in parallel, all in parallel. So how do we draw that? Right, I can make it like this. All of them I have to make it parallel. Okay, and it is given on a horizontal connection. Horizontal diagram is not given. I can take it in any ways. Okay, but all 4 lights should be in parallel. None of them are in series. How do we draw that? Any ideas? Can you suggest me how to make it? How do we make it? Any ideas? Can you show me the diagrams you have drawn? Yeah, show me the diagrams you have drawn. First question is related to diagram, right? Can you show me the diagram? This is Sharin. So you see, all of them are in parallel, right? All the lamps I have to take parallel. Let me connect the lamps first, and then I'll connect the switches. All the lamps are in parallel. Okay, lamps are parallel. What else the question says? Question says further, supplied at 200-volt AC supply. I can take the supply here. AC supply, I can't show dry cells. I will show like this symbol, a sigmoid symbol. Okay. And this is 200 volt. 200 volt. All the lamps are in parallel. Draw lighting circuit diagram so that there is one switch for each room. Each room, one switch. Each room, one switch. Okay. So let me take this as the bathroom. I have a switch here. I have a switch. I have here another switch. And then for these two, I have one switch. I have one switch for these two. So I can connect the switch here. I can connect the switch here. When I turn on, both of them are getting the current. I can't connect here because if I connect here, okay, that switch works only for this person, because if you turn on this, both of them would be working because the current would be in your passing. So I'm connecting here. This would be controlling both these lamps. Okay. And then it says each room and one master switch that will turn off all the lamps. All the lamps to connect somewhere here, I can connect. I can connect somewhere here. Right? I can connect somewhere here, even within this part, I can connect. Right? So this is the master switch. Label the lamps as 60 watts or 100. 60 watts or 100. Let me take this person. It is 60 watts. Okay. If I take the bathroom. And in the kitchen, 100 watts. And here the other one, I do have 260 watts. 60 watts, 60 watts. Okay. So this is my diagram. I don't want to take the horizontal because it's a circuit diagram. Okay. In a circuit diagram, the only word that is highlighted here is it should be a parallel diagram. A parallel circuit should be looking like this. Okay. And second question B. That was actually the first question A, right? Yeah. A. Question 2. A. Question 2B. The 100 watts lamp is switched on. Calculate the current in the lamp. 100 watts lamp is switched on. Right? Calculate the current in the lamp. How do I find out the current in the lamp? Only for that switch. Only for that. Right? That means this, without turning on this, you can't turn on this, right? So what it means, 100 watts is turned on means both these switches are turned on. Okay, while others are off. So now what I do for B, I want to find out, the question asked me to find out what is the current. What is the current? P is equal to P into I. So I is equal to P over V. If it is connected, what is the wattage? 100 watts. Dividing by what is the voltage? 200. So 100 over 200, it is 0.5 ampere. So what is the current flowing over there? 0.5 ampere current is flowing. 0.5 ampere current is flowing. That is the I part. Right? So it's clear. None of others are turned on. The charge passing through the lamp in 1 minute. The charge passing through the lamp in 1 minute. How do I find out the charge? I have already given you the equation. Charge is equal I into T. Okay? I equals Q over T. So Q equals I into T. Now I have the current. It is 0.5 ampere. Flowing in 1 minute means should be 60 seconds. Correct? 1 minute I can't apply. That should be 60 seconds. So half of 60, it is 30. And charges are measured in C coulombs. 30 coulombs. 30 coulombs. Then the 360 watts. The 360 watts lamps are replaced by 3 energy saving ones. 3 energy saving ones, they are replaced. That give the same light output but are rated at only 15 watts each. That means these three lamps you are going to replace it. You are going to replace it with 15 watts energy saving lamps. The total reduction in power. You want to find out the total reduction in power. How do you find out the total reduction in power? Now, total power. Okay, total power by each of the lamp, it is reduced by 45 lamps, right? 45 watts, right? Why? Instead of 60, when you're gonna use one lamp at 60 and you are replacing with 15 watts, means 45 wattage is reduced. Like that, 3 lamps you are going to use. So how do you find it out? You have to write like this. It is the C part 1. Okay. Reduction of power in one lamp is equal to 60 watts minus 15 watts, 45 watts. So hence, in 3 lamps, you are going to replace 3 lamps equals 45 watts into 3, it is 135 watts. 135 watts. Okay, 135 watts. Then the question says, the energy saved when the lamps are lit for 1 hour. What is the energy saved when the lamps are lit for 1 hour? How do you find out the energy? Energy is equal to power into time. So what is the power saved now? 135 watts. 135 watts power is saved. Okay. So that 135 watts power, it is saved for 1 hour. 1 hour means 60 minutes. 60 minutes means 3600 seconds. Okay, 3600 seconds. You got it? So then how do I find out the answer? How do I find out the answer now? You can see total energy. Let me take energy is equal to total energy equals power into time. Total power is 135 watts into 1 hour. 1 hour means 3600 seconds. 3600 seconds. How much do you get when you multiply this? 135 into 3600. 486,000. 486,000, isn't it?
Yes.
486,000. Yeah, 486,000 joules. Energy, right? Joules. 486,000 joules. Okay. So the question is asking you energy saved. Energy saved is 486,000 joules. Did you understand the way we got the answer? Yes. Fine. If you know the equations, you can easily apply. Easy apply. And one more thing usually that comes in this is about the efficiency. Efficiency. So how do you calculate the efficiency? That's not a question here actually, but usually it comes in the same like parts. Efficiency, how do you find out there is efficiency is equal to useful energy output over total energy input. Or else I can take output energy over input energy. Okay. And I have to take it as a percentage, 100%. 100%. Right? Let's say if a Sankey diagram is given in this way. Let's say a Sankey diagram is given. Okay. It's giving you usually left to right, horizontally we are showing the useful energy. Useful energy. And top to bottom we are showing the right. Top to bottom we are showing the wasted energy. Wasted energy. Maybe left to right or upward. Left to right or upward. Even upward I can show that is the useful energy. Wait, sorry. Top to bottom or upwards. Upwards or downwards I have to show the wasted energy. Left to right. Left to right I have to show the useful energy. Left to right, useful energy. Now let me take this. And I'm going to indicate something like this. Input energy is 150 joules. Okay. Wasted 100. Wasted 100. Maybe as sound or heat or whatever. Only 50 joules used. So how do you find out the efficiency? Efficiency is equal to useful energy is 50 dividing by, we don't take 100 now, total energy 150 into 100%. It is 1/3, right? 1/3. 1/3 means almost 33, 0.33 or else 33%. 33.3%. 33.3%. Okay, 33.3%. So this is how you get the answer. Sometimes the questions give you like this without mentioning the value. They will give you number of boxes. Okay, they will give you number of boxes. Let's say 20 boxes are there here. Let's say 20 boxes are there. How many boxes are there? Here. 20 small boxes are there. 20 smaller boxes are there. No any values given. No any values are given. Just 20 small boxes are there. You can count on the graph paper, 20 small boxes are there. And then here, it gives you at this point. This is the point now you have to take. Okay, look at this carefully. This comes in the questions. At this point, this level, from this point to this point, because this is the connection, right? Connection. It gives you somewhere, let's say, 8 boxes. 8 boxes are there. Okay. 8 boxes are there. This is the arrow. Up here, 8 boxes are there. Correct? And then, out of 20, if it is 8, definitely the remaining 12 boxes should be here. Right? 12 boxes should be here. So, this range is 12. So, you see, I didn't take this range, okay? I didn't take the vertical height. I have taken the width of the arrow. Width of the arrow. Width of the arrow is what we are taking here. Now 12 boxes are there. The question asks you straight away without giving any other units, asking you to find out the efficiency. What are you supposed to do? Efficiency is equal to these 20 boxes are what indicating the energy input rate, total energy input rate. 8 boxes, that is the useful energy. 12 boxes are the wasted. If the question asks you the efficiency, useful energy is indicated by 8 boxes dividing by total energy indicated by 20 boxes into 100%. 100%. So 21, 25, 5 into 8, 40% is the efficiency. 40% is the efficiency. So this is how, if no units are given, okay? If no units are given in a Sankey diagram, to find the efficiency, this is what we have to do. To find the efficiency, this is what we have to do. Okay. So could you please take the note, take the topic as efficiency. You have already theories, you have already done. Theories we have already done. These are the way the questions could come. Sankey diagrams also, some of the Sankey diagrams we drew. Taking the scales we drew, okay? These are the way the questions could come. Take the note, please. If you have any questions, you may ask.
So
Yes?
that means efficiency is a percentage from the energy.
Percentage from the energy, yeah. Means out of the total energy we input, okay, out of the total energy we input, what is the useful energy we are getting? For example, this has, let's say, okay, you are charging a mobile phone, for example, 100% you are charging, but that 100% you are not using, right? Why? When you turn on, the light is given out, right? Light is given out, the light is lost out, and a sound is given. Sound is somewhat you are using for the notifications and all, but ultimately it is a loss, right? Okay. So what is the fruitful energy, the beneficial energy you are using, that percentage out of the total, it is what we term as the useful energy. A grinder you take, you turn on the energy. Turning on the switch, electric energy is passed, 100 joules of energy passed, for example, right? Out of this 100 joules of energy, for the grinder to work, okay, the heat is also lost out. When it is working, the heat is also lost out. There will be a sound also given now. Okay. We are not using that sound, right? We are not using the heat, right? We need the object, the substances that we are giving to grind, to get down. Okay. So you see, the energy out of the total energy we are giving, we are getting the usage of a small amount of energy because most of them are heated or lost out as sound. Okay. So that is why we calculate the efficiency. What is the percentage? And whenever we are selecting the items, the goods, or any sort of objects, if efficiency is more, that is what we have to select. Efficiency more, powerless. Powerless means the power it consumes should be also less. Okay, let's say efficiency is more, but it says that when you are comparing, power it consumes is very much high. That means you have to pay a big electricity bill for that. One is 20 watts, the other one is 80 watts, means 60 watts more for only that object. Okay. So in that case, it should be high. Got it? Fine. So, like, any questions more? Sorry? Fine. So these 2 weeks actually we were doing some revisions as we are done with the related questions, the lessons and all. So next month, inshallah, I hope to start up with the new chapters. Okay. And probably next month we are starting up with the paper classes also. Okay. I'll update you once the days are fixed up. Okay, once the days are fixed up. I hope these like a night hours will be fine with you, right? Is that Shari? Are you okay with the night hours? Like not today, I mean not Wednesday, maybe another day for the papers to be done. We have to start up papers now. Okay, one by one, slowly we have to do for topic questions and then past papers. We have to start topic wise. We have to do the questions now. I hope these night hours will be fine with. Anyhow, I'll forward you the details. Then you can decide it accordingly. Okay. So with that, we are ending up the session today. See you at the next class. Please keep reminding the theories and reviewing the lessons. Okay. See you then. Good night.
Good night, sir.